In the previous video, we looked at our first creational pattern, the singleton. In this video, we'll look at the factory pattern both conceptually and in practice. The factory pattern replaces class initializers and abstracts away the process of object instantiation, allowing the type of the object created to be determined at runtime. This pattern consolidates logic that decides which implementation to instantiate into a single function inside of a factory class. The major benefit to this pattern is the abstraction of object logic and controlled management of object creation. We'll begin by opening the starter project for this video, which can be found on this video's resource page. This project is a console application that contains a few simple classes that connect and upload files to different cloud accounts depending on their file types. We've got one account for work-related files, one for personal files, and one for backup files. Of course, when you open one of these files, you'll see that we're not really connecting to a database. We're just printing messages to the console. The inclusion of that kind of development is outside the scope of this demonstration. We're only interested in the factory pattern here. So, in this hypothetical situation, we're tasked with uploading a batch of files to 3 separate cloud accounts. The file type is what determines where our files are uploaded to. Clicking through these classes, we can see immediately that they are very similar. Each has an account number, a password, and 2 methods for uploading and fetching. If we open main, we'll see 3 class instances, a file path variable that holds several strings, each with a different file extension and a loop with some logic. If we run the application, we'll see success messages printing to our console for our file uploads. The problem that we can solve here with the factory pattern is with our explicit instance creation and lack of abstraction around our logic. Right now, we're managing the creation of our objects ourselves. In a more complex situation, with many more account types and file types, this could not only become cumbersome, but it could even lead to potential issues. Not to mention that we have some very similar classes that have no real relation to each other. We'll convert this into a factory pattern, which will allow the type of the file we're uploading to determine the creation of our storage class type. We'll create a new file named Cloud Storage. Then we'll add a protocol with the same name. It will hold an account number, which will be read-only, a password, again read-only, and 2 methods, an upload method, which will take a file path, and a fetch method that is just there for show. Now we'll go through each of our cloud storage classes and make them conform to the cloud storage protocol, which should go pretty smoothly considering that our classes already implement each of the required properties and functions. Now that we have that in place, we'll create our factory class. Add a new file and class to your project and name it Cloud Factory. We'll start by defining an associative enum named file type. This isn't a requirement of the pattern, but it will help to improve readability. Our file type enum will implement Swift string type and will define our 4 cases. Images, which will hold a string with the PNG file extension. Videos with MOV. Archives with zip. And docs with pages. Of course, this is hardly an exhaustive list, but it serves just fine for this example. Next, we'll move on to our Cloud Factory class definition. We'll add a class function named accountForType. AccountForType will take a string and return an instance of a class that conforms to our protocol, Cloud Storage. I'll paste in the logic that will determine which instance to create. Here, we split our string at the period, and then we get the last item in the sequence and create a string from it. We'll pass that string into our enumeration, and then we'll switch based on the respective enum type. Finally, let's update main to use our factory instead. We'll remove our instance and the logic inside of our for loop. We'll then call our Cloud Factory's accountForType function and pass in our file. Thanks to our protocol, we can call upload since any possible type that will be created here is guaranteed to have an upload method. Finally, we'll pass our file into the upload method. I should note that we could have used initializers to get this file variable into our classes, but the factory pattern purists prefer that no initializer is used. One important thing to notice when looking at our Cloud Factory call is that there is absolutely no awareness of type. Our factory will pick out and generate the proper class instances based on the file that we passed in. We'll run this and, as before, we see all of our files being uploaded to their correct storage accounts. In this video, we have seen how the factory pattern can eliminate the need for explicit object creation. In the next video, we'll look at our first structural pattern, the adapter pattern, which can help us to adapt to incompatible APIs.